My name is Matej. I would like to personally welcome you to this event. We have prepared a little workshop for you about mining. I don't know how you guys, but me as a first user, my first contact with Bitcoin was through mining. After that, it took a big part of development. Lots have changed, and we're gonna tell you a bit about it. This is my colleague.
Hi, my name is Matej, with the same first name, and I would like to welcome you as well at this workshop. It will be about mining in general, and then later on about virtual mining. I would like to ask a question, as colleague already said. How many of you have done Bitcoin mining, some experience with it personally? About 1/4, okay, not bad. And how many of you know how it works? In detail. Okay. So this workshop is for people that, well, the first part is for people that have never had any experience with mining, so we will describe a little bit of personal experience. As I've been mining Bitcoins for more than 2 years, some other cryptocurrencies, so I will share with you my experiences. So what is Bitcoin mining? So mining is the process of adding transaction records to Bitcoin's public ledger of past transactions. So all of you know blockchain, right? Blockchain is the public ledger of the old transactions in the Bitcoin network since the beginning of its use, since 2009. So all the transactions are transparent. As an analogy to the bank, Bitcoin mining would be the work done by the operations department of the bank. Bitcoin does not have any operation department, they don't have any employees, so the work is done by miners. So a miner is basically nothing else than a computer or a piece of hardware that is connected to the internet, and miners compute hashes. So computing hash functions is only solving mathematical problems that are well defined at the very beginning. So it's nothing more than this. There are several types of Bitcoin mining of cryptocurrency, mining of cryptocurrencies. One of them is proof of work. This is the most common. Bitcoin, Litecoin, Dogecoin, transaction coin, and most of the cryptocurrencies implement this paradigm. There are others, proof of stake and proof of capacity. For instance, main safe is an example of proof of capacity, but we will not go into detail.
So as I think all you know that Bitcoin is runs on the protocol SHA-256. This was actually the first thing. First miners was like, at start Bitcoin could be mined on personal computer. You could turn on a laptop and mine Bitcoin there, but as development continued, it became harder and harder for normal users, normal people to mine Bitcoin. So no new algorithms were developed. For example, script. When it came, they said it's ASIC immune algorithm. So because it was using memory for the computation.
Actually, if I can interrupt, it was at the beginning of this year. Actually invested into GPUs in order to mine Litecoin and other script Litecoin, because I believe that there will be no one who will produce an ASIC for a script which is using memory. But unfortunately, for me, it happened, and I need to stop the mining of the GPUs. The GPUs are, I think, there.
Yeah. Then the script end changed the only one thing on script, that the memory needed to count was changing. It wasn't constant. So, but also for script end there are being developed ASICs now. And I don't know if you take look into news of altcoins, but currently, at the start of this year, there were, I think, 4 algorithms. And when the ASICs came also for script, there was, I think, altcoin boom, and there have been like another 15 more algorithms to mine cryptocurrencies. So I'll introduce you to hardware about like, so the basic computer is CPU. You got computational processor unit. You can use it. It's intelligent system that you can use to run softwares, watch movies, play games, anything. That was the first thing that was used to mine Bitcoin. The GPU was used for script because graphical processor unit has also the memory. FPGA is a bit more, how would I say it, a bit more direct way to mine because it's programmable unit, motherboard, that is programmed to mine, but the efficiency is not that good as ASIC. ASIC is the most advanced solution. You could say that ASIC is actually a simple thing, like it cannot do anything else, just solve the one algorithm that is designed to. It sounds like it's simple to do, but like to develop ASIC, it takes like the steps in it are you have to first develop FPGA, which costs loads of money, and to apply when you have the working thing, you want to apply it to ASIC, and those costs of ASIC development are for one chip. It's cost about $8 million. So many companies that are selling now the ASIC miners still use old Avalon 28 nanometer chip, but this difficulty that we have now, it's not easy the power consumption is so big that the difficulty is rising up, and it's not more profitable. So the companies need to develop new chips still. Like a KNC miner they do those things.
20?
Yeah, they have a 20 nanometer chip, and I think somebody announced now that there's going to be a 60 nanometer. Yeah, so this is classical CPU. This is how a GPU, actually this is my miner that I have at home. Yeah, it's homemade.
How many GPUs you have?
There are 6 GPU units. I think they are still actually pretty powerful, but not with when ASICs came, we just turned it off. This unit has 5 mega hash. It's not a lot now, but at that time it was. And the power consumption is 3,000 watts. And if you buy an ASIC miner for a script now, I think with 1,000 watts consumption, you can get about 250 mega hash. So it's impossible to pay the bills for electricity.
When competing with a large number of ASIC miners, difficulties.
Actually, on start of the year, the difficulty of Litecoin was about 3,000, and now I think it rose up to something like 35,000. So this is how a FPGA looks. I think those are the first FPGA miners from Butterfly, I think. You can see. And this is how mining looks now. This is one of the mining took a big step into industrial mining. People are investing huge amounts of money to build mines, Bitcoin, and they have hundreds of processors and ASICs, and the whole building set it up for it.
It was a factory in China, basically. But someone rented the factory space and employed people and made a company.
So there are many ways. Like actually, we're gonna show you there how to mine here. Electricity prices are the main thing. If you want to set up a big mine, you need to look for a country where you have stable internet, stable electricity, and cheap electricity. In Slovakia, I think for 1 kilowatt you pay about 12 or 15 cents. So if you count it up, my bills per month were like 400 euros. So but the easy way that we're gonna do here is to use someone else's electricity illegally. It's called squatting. You can just connect to the network, nobody knows about you, and you can mine. Yeah. I can show you here the coin bars. It's a website where you can see the mining profitability. I would show it on Litecoin, I think, for script.
So many coins in there.
Yeah, let's say I will first show it on. When I was mining about 7 Litecoins a day. So currently, if I would use my hash rate and my power comes up, assumption, but cost of electricity, let's say like this. So with this difficulty, I would actually hourly lose 43 cents. So that's what happened when the first ASICs came. Everybody started to lose money. Every guy who was owning a GPU just wasted his money on it.
And moreover, the value and the exchange rate of altcoins went down as well. So this is another factor.
Yeah. So that's the thing. When the ASICs came, like week after, the company, Radeon, announced a new GPU. It should cost like one GPU like that costed at that time about $500. And Radeon produced a new GPU. I think they charged it also on miners there because they put the water cooling there. You see those cards are air cooled, and it's not quite easy to have it at home because it's heating the whole house and it's really noisy. If you have a girlfriend or wife, she just cannot plug in hair dryer because the power will go off. So you have an angry wife, and you're losing money now.
You can save on heating bills.
Yeah. Those mines, as I showed you before, that are in China, many of people now do cloud mining. You don't have to buy any hardware. You just have to pay a price per month. You have many companies that are offering that you rent hashes. You pay per month or per year, and you get your bitcoins. The thing that but you still have the risks there because you don't know what difficulty will Bitcoin have in 2 months. So you rent 1 terahash for let's say, I don't know, $2,000. I don't know the prices now. And in 2 months, you rent it for a whole year. In 2 months, the difficulty can be so high that actually you will also lose money. So it's a risk still.
You can even burn on it if you can break even in your couple of months.
Yeah.
So it's a risk, but what is good about cloud mining is that you don't need to have any technical background to understand mining. Just the one-click solution. You rent it, you pay, that's it. You're mining, looking at your charts, how much you are earning and losing, and no electricity bills, no hardware.
Yeah, actually setting up a miner like this is sometimes really painful. You never know what happens. But something doesn't work. Sometimes it takes days to find out what was wrong with it.
So now I would like to tell you a few words about the blockchain. When he's talking about blockchain, so the blockchain, picture of blockchain, there are blocks of transactions, and the blocks point to each other in the way as shown with the blocks data structure. What we can see is sidechain. It's part that is not in the main blockchain. And the Genesis block is the first block of Bitcoin, the blockchain that was mined in 2009. Now, what is a hash function? Bitcoin mining, hash functions is used. How many of you know what the hash function is? Quite a few. Okay, so for the others, hash function is a signature for text or data file. It's one of the definitions. Simply speaking, it's only a function that transfers the input into an output. The output is generally different from the input. And what is a good hash function? The good hash function is that the spread between outputs is big. So, for example, you insert into hash function 1, you got some output, and if you insert 2, which is close to 1, you get a different output, and the output should not be very close or similar to the previous output. Also, the outputs of hash functions are generally padded to a certain number of characters. For instance, SHA-256 that is used for Bitcoin is 260, that we can simply something can verify it here. I made a small program in C in order to find this out.
But the important factor also of a hash function that is not reversible. If you have an output, it's the reverse part of it it's really impossible.
Because if you get the hash, it should be difficult not to find the original input. If you find the output, it shouldn't be. One example of a very bad hash function is just +2, right? For certain amount of values. So if we run it, should be compiled. So let's say I use 2, right? And what I get is 4. So what it does is just +2. There's an example of a hash function for a certain set of values. If we have a look at the source code. It is in C. There is an integer number, right? That is just plus equals to this to an outputs result. So very simple. It's a very bad hash function because if you see, for example, 5, and you can see a certain set of numbers, you can find very easily what it is. But this kind of function could be used to create your own cryptocurrency. It's called simple coin, and another simple hash what is used is the ASCII sum of the characters. It would work for a string. So in computers, operating system, usually the characters, for instance, A, B, C, D, E, and such, have some ASCII code that should be defined on the ASCII table. There are different ways of coding used, of course, but take the simple one. Okay, so if you have a look here, capital A has 65 as an ASCII code, right? So if you have a string A, B, C, D, E, So the hash of it would be 65 plus 66 plus 67 plus 68 plus 69. And the final number would be the hash, right? If we take, for instance, numbers and their SC code as well, we take, for instance, 2, we want to insert a string 234, so it would be 50 plus 51 plus 52. So the final hash would be 153. And if I give you the number 153, and you know nothing about the hash function I used, if I give you only that number, you will not, only one output, you will not be able to find what hash function I used for it, the sum of ASCII, right? But if I give you more than one, let's say 2, 3, 5, 7, 80, a bigger sample, you will be able to determine by the simple analysis of the output. So this is another type hash function. What is used in Bitcoin mining is SHA-256. Okay. I just wanted to show the specification of this. So it's a little bit more complicated knowing some of the characters as in code. So for example, SHA-256 of an empty string is this value here. So it's quite long. I don't know how many characters are there. Does anyone know? Maybe we can just count them to see. So I think I guess like so there are 65 different characters that are the signature of an empty string. There are other hash functions as SHA-384. I think it's much more. It's something about 80, 90. SHA-512, even more and such. But the one used in Bitcoin is this one. So this is the actual pseudocode of the function or specification. So it's much more complicated than what I wrote for the simple hash function plus 2. You can of course read this and implement it in your way to be able to do hashes. But mine is more complicated than only doing hashes. There are private keys and public keys that are integrated into the hashes and the inputs, but we are not going to talk about this because we don't be able to cover all those features now.
So with 256, you can't see what the input is? Based on an output, you can't see what the input is. You can't reduce the input.
Yes, that's the point of it, that it's irreversible. You get an output, you even can know the function, but you just cannot count the input from it, because it has too many possibilities.
Yeah, you've got a set of outputs, and not knowing the hash function, the algorithm, it is very difficult to get to the inputs. So we can have a look at this thing here. This actually someone just coded, someone just implemented the SHA-256 in here. So let's use the empty string, right? I insert nothing, and I compute the hash. So it is E3B0C. You can have a look here if it's right. E3B0C, right? Here. And I finished the 855. 855. Yeah, it's here. So let's use someone's name. So Adam. Your hash would be this one.
Should tattoo that.
F7 and 37. It's all in hex, so we can convert this into binary or decimal. Should be. You should get a number. Choose your name, my name. So we got OB84CF6 and such, and if we just change this letter to a capital M, so we get OB84 for small m, and we change and we got E368, so we got a string that is totally different from the one we used before. So basically this is the information. There's someone who wants me to hash something else? Okay, let's try BTC2B. Okay, 3 or 7. Okay, let's get back to the slides. I'm going to tell you a few words about merge mining. Merge mining is a phenomenon that is known for quite a while. One of the first points that came out with this was Namecoin. And Namecoin were mineable using the merge mining phenomenon with Bitcoin. So if you are mining Bitcoins, you can basically get, thanks to merge mining, some other coins for free of charge. So this is thanks to the fact that the most costly operation on your mining hardware is the computation of the hashes. So what I did before, if you're computing Adam's mining and such, so this is the most difficult operation. And what is not that difficult or hard is to insert those hashes, those outputs from those hash functions into the blockchain. So, and what merge mining does is that they do not, the hashes are computed once, so the hard work is done only once, and then the outputs are easily inserted into several blockchains. Let's say two, the case of transaction, for instance, or Namecoin. So as I wrote here, complete once is twice, and it is all about the expensive hash computations versus cheap insert into the blockchain. And we are going to set up some mining and keep it here until, maybe not here because it's a bit noisy, but somewhere in these premises, till the end of the Congress, and we will be mining transaction coin to merge with Dogecoin and Bitcoin, and you can get all those coins for free. If you sign up until this Sunday midnight at that email address, DexQ@BTC2B.com. We will divide the number of participants. We will divide the number of mined coins by the number of participants. Good question, yeah?
Yeah, how exactly do you merge mine Dogecoin with Bitcoin? Because those are two different algorithms.
No, I wanted to, sorry, I didn't explain myself properly. Yeah, it wouldn't work. The merge mining is for transaction coin, and what transaction coin implements, I will talk about this on the next slide, I believe, is double algorithm merge mining. So you can mine transaction coin either with Bitcoin or with Dogecoin.
And can you do it at the same time as well? So you
probably not on the same hardware, but it depends on the kind of hardware you are using. If you would be mining on your laptop, you probably can if you mine with the CPU. So let's say it would be the same hardware, right? Your laptop, your CPU, and you can mine. But it would be not very profitable. You will not get any DexQ or Dogecoin or Bitcoin.
As said before, there's a link. If you create a wallet and send us the wallet address to to the email, we will send you the transaction coin to your wallet.
It works only for Windows. Right now, I believe on everything Mac and Linux versions available soon. What I wanted to add is that on this setup here, we've got 3 GPUs. There is one on the motherboard, but we are not going to mine on that one. And we will merged mine transaction coins with Dogecoin on the GPUs. And we've got some 2 small ASICs in the USB hub. You can see there that are, well, I would put them in a museum if I could, but we can still mine some transaction coins. If you have a difficulty still. Transaction coin has currently about 240 miners on their S-Script pool, merge mine with Dogecoin, and they have a smaller amount of miners on the Bitcoin mining pool. Bitcoin mining pool, sorry, it's the inverse. Yeah, so bigger amount of miners on the Bitcoin mining pool, a smaller amount of miners on the Dogecoin mining pool. So this is the website, www.transactioncoin.org. And but I had a question from the gentleman before about how to mine Bitcoin with Dogecoin. So what was first in the merge mining field was single algorithm merge mining. Was the case of Namecoin. So in that case, the virtual currency has only on blockchain, and is mineable, merge mineable only with the other currency, only in one other currency. But the advantage of transaction coin is the double algorithm merge mining is SHA-256 and S-Script. S-Script is just a different algorithm. It's SHA, the principle, the basic principle is the same. So with transaction coin, one can mine Bitcoin and Dogecoin merge mine. And the main advantage of one of the advantages, besides that you get some points for free, is that it is less vulnerable to 51% attack. Given that if someone starts a new coin, it could be considered a good idea to start it to be merged, develop it to be merged mine with another well-known cryptocurrency, such as Bitcoin and Dogecoin. Bitcoin obviously has a very big community, but the Dogecoin too. I think Litecoin is not that famous. People are going to use this mainly as a store of value in China. So given that you can merge mine your coin with another coin that is well known, you are more likely to get a bigger user base. So it will be more decentralized and less vulnerable to 51% attack. Because as almost all you probably heard about this, come from the Bitcoin space, but for those who haven't, it means that if an entity gets more than 50% of the mining power, the world mining power of Bitcoin, they can take over the network and do basically what they want. So it almost happened with Ghash. A couple months ago. Yeah. 4 months ago, they got about 45%. So let me tell you a few words about transaction coin. Transaction coin, or TXC or TX coin, is a double algorithm merge mining coin. It was born 6th of June of this year at GMT 6 a.m. 6 seconds. The average block generation time is 2 minutes, which is an advantage compared to the Bitcoin generation time, which is now 10 minutes. So the transactions get confirmed faster, and you can basically pay faster. And as I said, next to merge mining, you can get free DexQ with mining Dogecoin and Bitcoin. Well, some more technical details of difficulty. You're talking about 720 blocks. The reward started at 1,000 and it will get to 25. transaction points per block solved, and the reward is halving every 500,000 blocks, and the total supply would be 100 million transaction points, which is about 5 times more the total number of bitcoins. Yeah, 7 right? It's 100 million. So it supports arbitrary message, allows associate extra data with transaction that is secured by the blockchain, and there is a message delivery function. There is a way to see the messages and on the transaction point network, and also list one is a decentralized advertising. So now we could move to the practical part. Shall we merge mining?
Yeah, and this is the sound if you mine which you get home 24/7.
Only if we are not mining yet, so it would be even worse. Meanwhile, if you have any questions, please feel free to ask.
I do have a question. You have to, if you find a hash, mining is finding a hash, right? You have to find a hash with a certain amount of zeros, right? So it's like a 64 or 65 digit number, with first number has to be a 0, second one has to be a 0, and when the difficulty goes up, you get more zeros, right?
Yes, more required zeros.
Yeah. But if the difficulty goes up from 6 zeros to 7 zeros, it's a big step.
Of course.
And then mining should go from like 8 minutes for a block to like 500 minutes for a block. So isn't it that they, how do they do that?
It's not just zeros, it's everything between 0. So the first couple are zeros.
Yeah.
The last one is, so first you do like that's lower than F. F is the highest in X decimal, it's 16. Then it needs to be lower than 15, and then 14, then 13. And then when they get to 0, they just go to the next number. So they have like gradual steps.
So the steps are like from Z to...
No, it's from F, and then so it's F, G, A, so F counting to A,
Yeah.
and then from 9 to 0. And then 0 is the lowest, and F means 16.
Yeah. And these are still small steps.
Yeah, so the difficulty can be pretty gradual, yeah. And I think...
Yeah, and the difficulty factor, let's say the number of zeros in this simplified explain. Difficulty is increasing when there is more hashing power in the network. And the total of the hashing power in the network rises, then the difficulty rises as well. And this is called the difficulty retarded, which transaction point has every 720 blocks. What's the case for Bitcoin? Do you know how many blocks?
I don't know if there are blocks.
I'm not sure about this.
I think it's like every 2 weeks, and it's like a block in 10 minutes, right?
Yeah.
That's like a couple hundred.
That's an average, so an average, yeah, 2 weeks. What is this invariant is number of blocks over time, right?
Yeah, so in 2 weeks it's like 14 days times how much in a day? Like 640, 240, yeah, so like 500, 400, something?
Probably.
150 times 14.
Yeah, exactly.
So mining is looking for zeros.
Yeah, it's completing hashes. Right, in a way that it has certain number of zeros or it fulfills any other conditions that are implicitly not that So
But
all of
it's
this,
not, it's not usually the computing hashes that are taking an input and getting an output. That's what takes up a lot of power.
yes,
But when you actually get a block, like the lottery, so to speak, that's when you get the right number of zeros.
Yeah.
When you're going
Yes.
through the process of
Yeah.
computing.
yeah,
So I compute a hash, and that hash, if it's got a certain amount of zeros, then I get the block.
exactly what you said. But the competition is high right now. Your approach was usable, let's say, in 2010 by laptops, right? I mined on my laptop in like 2010, right? I got hundreds of Bitcoin by the back. But now what is used is a mining pool. So what is a mining pool? Mining pools allow people who do not have enough hashing power to solve a block to find the number of zeros as described, the hashing a certain number of zeros, but actually can work together, put their hashing power together in order to solve the block. And then the block, the reward from the block for Bitcoin is 25 Bitcoins. It's divided by the number of shares. Let's say the number of computing power each individual computer or miner provided. So this is how you can mine today. Mining without the mining pool and without having such a farm. Matej showed you before. In China, it's really difficult. The probability of solving a block is very close to zero.
But if you're in a pool and you have computed a hash and found the right number of zeros, why would you have any incentive to share that block?
Because you are mining through the mining pool, and it is the mining pool who is paying you. You are not getting the reward. The reward is paid to the mining pool.
So they're controlling the hash and power.
Exactly. In order to be fair for everyone and to permit.
Yeah, and also that the thing you are hashing, it includes the address where the money needs to be sent. And you have to put the pool address in there. So you can't really compute it as part of the pool, and if you get it, then let it go to the pool but to like your own thing. You can't do that because you have to get the address in, which is part of the hash. So if you change the address, then the hash won't match anymore. Okay?
Yeah, because you have to find a hash from the signature from the last block,
Yeah.
from the transactions in the block,
Yeah.
from the fees.
Yeah, exactly. And also
In
for
your
the
own
payout
address,
address.
right?
Yeah. Yeah, that's basically another transaction you're adding,
Yeah.
which doesn't have an origin. It's like
If you and
generate.
that transaction, if that's your own address, you have to find a new hash again. So
Exactly. Yeah, and if you put your own address in, then the pool will say, I'm not going to do this. I'm not going to even going to check it because it's your address.
Yeah.
So you're not going to get payout if you calculate your own address. But yeah.
Yes. Any more questions? Okay, so let's move on. I downloaded the free software. It is open source CD miner. I just unzipped it. My Litecoin is this one. Yeah, there might be for mining DexQ, but I let Matej first to show you the mining. Or is on this computer? I think it's here. It's there. Okay. So I will show you the mining pool. What that looks like. Close the hashes. Okay. Do you know? So this is a website. It's Shark 156 is the name of the algorithm goes transaction coin mining goes on. And on this website you can connect your miner and mine transaction coin in Bitcoin. So it's not performed yet. So this is an ASIC. This is a USB hub. This is a fan, and this is an ASIC line. Well, the first ASICs were released in form of USB key. It can mine, I believe, 336 megahashes per second, and the miners that are sold now are in units of terahash. You can buy 100 of terahash miner from the company, right? So this is just a very not significant at all. You cannot mine anything to this. I bought those miners last summer, 2013, for 1 Bitcoin. One miner cost me 1 Bitcoin. At that time, 1 Bitcoin was about 60 euros. So this is how much I paid. I was not able to break even, but I bought it because I wanted to have an ASIC. So let's turn it on first.
Actually, the latest miners, I think one machine has about 6 terahash. So that's the difference.
6 terahash?
This was
It's up
300.
336 megahash per second.
Yeah. It's like 180 of the new one.
1 terahash is 1,000 megahash. No, 1 million. 1 million. So, yeah. If you divide it, it's zero. Megahash. 3 of them you can have a listing.
Actually, I think the latest ant miner is big like this, and it has 220 cache, so that's a big difference.
So this is the pool, mining pool, DexCoin, and BitcoinMarketing mining pool. You can see there are 223 workers. The pool hash rate is 261 terahash per second. So I have here 336, I have two, about, let's say, 700 megahash, so it won't my much, but I think you can get some terahash. The difficulty is still low. We are not mining right now, so our hash rate is 0. So let's turn it on. Okay. Just double click on the screen. Pressing D.
Yeah, so now I turned on the Bitcoin AC miner.
No device affected. There is a problem. Okay, let's restart it. See if I unplug it and plug in another port. Wait until the driver is loaded. So you can see how the script is written. There's a timeout at the beginning. There are some parameters after, and then we are using the free software CD miner. We use the address of the mining pool port. The port is 333. The password is BTC2B.worker1. The username and the password is X. And after there are some settings in order to make the ASICs work. So I hope I just check the USB port. It's all connected. we are missing one table here. Okay, something is installing here. Okay, so you're working. Good. So let's turn it on. Okay, currently got only one, the ranks of the wrong port, but it's working. You can see here the hash rate is 232.5 megahash per second. The rate will be bigger. Okay. So we are currently mining on one of them. The one is not connected, but for demonstration purposes, works. The hash rate is 340 megahash per second. And if you check it on the mining pool, cannot see yet. Get some time. So in the meanwhile, I can turn on the GPUs. For that purpose, okay. 9 keys you want. We are launching the GPUs now. 9 keys 2.
So as you can see on the left corner, there's a temperature of the graphic card. Like the normal operational temperature was about 30 to 50 degrees, and now, as you can see, it's really rising up. That's why you need an external cooling, because you are overclocking the GPUs, and the cooling system on the card is not produced for this load.
There's a nice amount of heat already coming from here, and if I turn it on off for a second, you can hear the noise of mining. The noise as these rooms that we want to use, so we cannot hear it properly. So I will just turn the cooling on. There is a significant difference. It's because of the mining. Currently, we are mining with this amount of kilowatt which is coming out. So if you check it on the website, this is our hash rate. All the amount of currently, if you have of course more on the computer, so if you like to learn to mine transaction coin, you can go to this address, script.dexq feel free to ask.
Thank you.